Hello all from E-Chemistry class, Fatima Convent High School. Myself, Dipali. Chapter 2 Is Matter Around Us Pure? In this session, we'll study about physical and chemical changes and types of pure substances. We know that this world around us is completely made up of changes. Every minute, every second, there are changes occurring around us. And there are various forms of changes. Out of them, we are going to study today physical and chemical changes. What are physical and chemical changes? In the previous chapter, we have learned about a few physical properties of matter. The property that can be observed and specified, like color, hardness, rigidity, fluidity, density, melting point, boiling point, etc., are called physical properties. The interconversion of states is a physical change because these changes occur without the change in composition and no change in the chemical nature of the substance. Although ice, water, and water vapor all look different and display different physical properties, they are chemically the same. Both water and cooking oil are liquid, but their chemical properties are different. So, the substances with just change in their physical properties is called as physical change. They differ in odor and inflammability. We know that oil burns in air whereas water extinguishes fire. It is this chemical property of oil that makes it different from water. Burning is a chemical change. During this process, one substance reacts with another to undergo a change in chemical composition. Chemical changes bring change in the chemical properties of matter and we get new substances. A chemical change is also called a chemical reaction. During burning of a candle, both physical and chemical changes takes place. Why? Because the size of the candle becomes smaller and the wax changes from a candle shape to a heap. So that is a physical change. But when the candle is burning, certain amount of wax is burned and converted into vapor form. So during that, we can say it is a chemical change because the composition of wax is changing when it is burning. This is how a burning candle shows both physical and chemical properties. There are various other examples of physical and chemical changes, like rising of sun and setting of sun is a physical change, whereas burning of paper, burning of sugar is a chemical change. You can list innumerable examples of physical and chemical changes. To differentiate between physical and chemical changes, if the physical properties show any change, it is a physical change. If chemical properties show changes, then it is a chemical change. Now, what are the different types of pure substances? We saw different kinds of mixtures. Now, let us see what are different kinds of pure substances. On the basis of their chemical composition, substances may be classified either as elements or compounds. Elements. Robert Boyle was the first scientist to use the term elements in 1661. Antoine Laurent Lavoisier in 1743-94, a French chemist, was the first to establish an experimental useful definition of an element. He defined an element as the basic form of matter that cannot be broken down into simpler substances by chemical reaction. The elements can be normally divided into metals, nonmetals, and metalloids. So, the elements are said to be the pure form which has same kind of atoms or molecules in them are called as elements. And there are total 118 elements found till date. And they are classified into three main categories: metals, nonmetals, and metalloids. Metallic properties are usually as below. Metal usually shows some or the all of the following properties. They are lustrous, means shining, like the silver coin or a aluminum metal. They have silvery gray or golden yellow color. They conduct heat and electricity. They are ductile, means they can be drawn into wires. You must have seen wires made of aluminum, copper, steel, etc. And they are malleable, can be hammered into thin sheets like the aluminum foil. And there are various other kinds of foils available for various purposes. They are sonorous, make a ringing sound when hit. So, the examples of metal are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is liquid at room temperature. Non-metals usually show some or all the following properties. They display a variety of color, they are poor conductors of heat and electricity, they are non-lustrous, sonorous and they are not lustrous, sonorous or malleable. Means they do not produce any sound on hitting, they are not shining or do not convert into wires or sheets. Examples of non-metal are hydrogen, oxygen, iodine, carbon, coal, coke, bromine, chlorine, etc. Some elements have intermediate properties between those of metals and nonmetals. They are called as metalloids. Examples are boron, silicon, and germanium. They show certain characters of metal and certain characters of nonmetal. So they are called as metalloids or semi-metals. The number of elements known at present are more than 100. Till date, it is 118 because the last year was counted as the periodic table year. 92 metals are naturally occurring and the rest are man-made. Majority of the metals are solid. 11 metals are in gaseous state at room temperature. 2 metals are in liquid state. 2 elements are in liquid state at room temperature, mercury and bromine. Mercury is a metal, bromine is a non-metal. Elements gallium and cesium become liquid at a temperature slightly above room temperature, that is 303 Kelvin. So this is an account about elements. Now let us see what are compounds. A compound is a substance composed of two or more elements chemically combined with one another in a fixed composition. Divide the class into two groups. Give 5 grams of iron filings and 3 grams of sulfur powder in a china dish to both the groups. Mix and crush iron filings and sulfur powder. Mix and crush iron filings and sulfur powder. Heat the mixture strongly till red hot. Remove from flame and let the mixture cool. Check for magnetism in the material. Bring a magnet near the material and check if the material is attracted towards a magnet. Compare the texture and color of the material compound contained by the group. Add carbon disulfide to one part of the material obtained, stir well and filter. Add sulfuric acid or dilute hydrochloric acid to another part. The material obtained, perform all the steps with both the elements iron and sulfur. You will observe that the gas contained by group 1 is hydrogen. It is colorless, odorless and combustible. It is not advised to do the combustion test of hydrogen in the class. The gas obtained by group 2 is hydrogen sulfide. It is colorless gas with the smell of rotten eggs. So you can easily say what type of properties the compounds are showing. The properties shown by these substances are called compounds. You must have observed that the product obtained by both the groups show different properties, though the starting material were same. Group 1 has carried out activity involving a physical change, whereas case 2, Group 2, a chemical change, a chemical reaction has taken place. The material obtained by Group 1 is a mixture of two substances. These substances given are the elements iron and sulfur. The properties of mixture are same as those of its constituents. And the material obtained by group 2 is a compound. On heating the two elements strongly, we get a compound, which are totally different properties compared to the combining elements. The composition of a compound is same throughout. We can also observe that the mixture and the color of compound are the same throughout. Thus, we can summarize the physical and chemical nature of matter in the following graphical organization. Now, matter. You can see they are solid, liquid or gas, and they are classified into two basic groups, pure and impure, which is also called as mixture. Now, these pure substances are further classified as elements and compounds. Elements cannot be broken down into simpler substances. Examples are copper, oxygen, iron, hydrogen, mercury, etc. Compounds have fixed composition, can be broken down into elements by chemical or electrochemical reactions. Examples are water, methane, sugar, salt, etc. The mixtures are of two kinds, homogeneous and heterogeneous. Homogeneous have uniform composition and examples are sugar in water, salt in water, sulfur in carbon, disulfide water in alcohol, etc. Non-uniform composition, for example, sand and salt, sugar and salt, water in oil, etc. These are examples of heterogeneous mixtures. So, this concept of physical and chemical change and mixtures, elements and compound should be thorough. Now let us see the difference between mixtures and compound. Mixture can be of element or compound just mixed together to form a mixture and no new compound is formed. Elements react or undergo chemical reactions or chemical change to form new compounds. A mixture has a variable composition. The composition of each new substance is always fixed. A mixture shows the property of constituent substances. The new substance has totally different properties. The constituent can be separated fairly easily by physical methods and the constituent can be separated only by chemical or electrochemical reactions. So, this is the main difference between mixture and compound. Thank you.